Thank you for the opportunity to speak once again at Supply Chain Tech. This must be my fifth rodeo, I think. Quick thank you to SAP. In my last startup, actually, SAP was one of our best partners. Can't say enough good things about them, and obviously the fantastic installations. So DeltaTrak, we're a company based in the East Bay in Pleasanton in California. Basically, we do cold chain. We've been doing cold chain for 35 plus years. When we started out using paper-based temp recorders, obviously then that migrated to digital. 6 years ago, there was convergence, obviously, of real-time. So real-time IoT, location, time, as well as temperature, humidity, shock, and some of the other variables. We do work with some of the largest companies in this industry, but obviously on the grocery side, the Krogers, Costco's, Walmarts of this world. Also some of the brands, the Dole, Sunkist, so, we've got quite a lot of, anecdotal evidence of what works in terms of supply chain for produce. And here's really what I'm calling the produce trends. And probably the big one, the big elephant in the room right now is food waste, right? I don't think there's any other supply chain that people have contact with where you're going to end up throwing 30 to 40% of that product away. I don't think it happens. In chemicals, you'd be losing money. Automotive, you'd be losing money. Produce, we get to do it and we still make a little bit of money. But we think it's actually growing and it's out of control, and we need to see how we can try and manage that for the benefit of everyone, right? Population's growing, people need food. It's obviously it's more than a shame that then we're throwing away so much of the food that, people need in some shape or form. The second thing, and this is probably a little bit more US-centric, there's some regulation coming. There's some quite complex food regulations coming to do traceability, coming from a government perspective. And what they're really trying to do with traceability is actually public health. It's around the recall. But you can't do efficient recalls until you do traceability from the farm, the producer grower, through to the supplier. Maybe you've got a wholesaler and then finally the retailer. So that's happening. It's coming into law in January 1st, 2026. And probably the biggest part of that is what's called the traceability lock code, which allows you to trace food all the way back to where it was sourced from. Actually, sometimes that's quite good, but they didn't really get the format 100% correct. So there's a bit of a fudge on the data. They've let people define what that universal code should have been. So there's a lot of nuances there of how to build up, if you've got thousands of suppliers, each of them maybe with a different implementation of the traceability lock code, how to make that happen. And then I think the other one obviously is sustainability, right? There are some regulations coming around sustainability, specifically carbon emissions. If you're a company in California, that's becoming quite soon. If you're a large carrier, marine carrier, going into European ports, that's also an issue right now. You will need to kind of do your carbon emission accounting and calculate them. And again, this is important for the world of food because, again, if you throw away 34% of the food, 30 to 40%, you've already incurred all the emissions, right? So a good way to get rid of some of the emissions is actually have better food and less of it, but just deliver it in better quality that people can use in peak condition. So the USDA, this was a while back, probably about 8 years ago, started to kind of encode what good practices for different food commodities, right? And every single produce commodity is in this handbook. It came out, I think, 2016. It's got 792 pages. Basically, what it does, it tells you on a commodity by commodity basis, by, if you like, a fruit or variety basis, what the respiration curves for those produce, is from cut to cool all the way through the supply chain to when it's actually at the supermarket, probably to the DC. What we did in DeltaTrak was understand that process and start to say, okay, well, if there's already these respiration curves, maybe that's something we could look at encoding in some kind of graph, run it against our, if you like, our loggers or our tracker data, and then come up with an estimation of shelf life degradation, right? The avocados from Mexico, so typically an avocado from Mexico is going to the US, and they say 4.5 days it has to be on a supermarket shelf. And actually, the journey is planned out in some shape or form to actually manage that time, so it's ripening on the way. If it's going in a container, they want to keep it dormant, and then they actually have ripening centers. They've got the stock, and then they manage the ripening process to make, fulfill the demand and the orders that they have with customers. Okay. This is, again, from the investigation we did. So actually, we started some work off with the University of South Florida. We actually created a patent around this model, but we broke up the temperature deviations in three parts, right? Anything that's happening here in what's called harvest pre-cooling. Okay, so it's harvest and pre-cooling. Okay, so this is being picked, and then obviously this is when it's going to the cooling station, see where the temperature plummets. Okay, that's good. Here's a fairly flat line. That's the actual shipment of the goods through the supply chain to the DC. Door opening into the cold chain, and then this is actually then into the longer like food network, which is DC to store, store on shelf, shelf to consumer. Okay. What we can control with the data really is up to this point, right? Once it's actually at the store, there's a lot of other variables that we don't really have in the model. Conversely, at harvest, precision agriculture, there's a lot of data points you can capture as well that might have some shape or form, impact on the quality of the goods, right? How much water has happened, what was the natural rainfall. So we've got a customer out right now shipping out of South Africa. It's been raining for 2 weeks in this particular region of South Africa. They haven't been able to ship anything. So they're kind of measuring what's happening with the rainfall, make sure it's getting enough water, make sure it dries out with the sun, and then picking at the optimum conditions to make sure it arrives to market. But that's typically, what we're looking for temperature and shipment duration. And, this is what happens if it doesn't go well, right? I think everyone's had an experience of having an avocado. We buy it in the supermarket and they do two things. They just stay hard. Okay. And then you kind of worry and try and accelerate that process. Or we buy it, we check it in a day or so and it's already gone off. Okay, and this hidden shelf life is what we're trying to capture in this model. Something that can't be captured so easily on your typical inspection that the receiver is going to do when they receive goods at their warehouse. Visually you will see on the outside on an avocado that there's bruising, there's some mold, maybe there's issues. It goes black. There's maybe some odor issues. But some of them look perfect on the outside, but because there was a temperature exception, when you cut them, 2 days' time, you're not going to get that peak freshness. So that's what we're trying to avoid. We want to make sure then there's no peak product in the hands of consumers for the maximum amount of time so we're not wasting it. We're actually using it, eating it, rather than throwing it away.